Here is the summary of this video. What is the issue? Lorentz transformations are the foundation for relativity theory calculations, such as the gamma factor, kinetic energy, and the addition of relativistic velocities. If the derivation of the Lorentz transformation was false, the theory of relativity would collapse. In this third video, we will critically examine the start of the derivation with the link between v and v prime. Previously, in the previous videos, we saw that these were specific reference frame S and S prime, where the origins of place and time coincide. In addition, the new derivation concerns that a light wave emitted at O and O prime, at the instant t equals t prime equals 0. In the usual derivations, y prime is equal to y, and there is a link between x prime and x. During our analyses, we were unable to establish these links. Derivations. In the derivations, there are three types of arguments.
These squeeze rotation-y things are called Lorentz transformations, named after one of the first people to derive the correct mathematical expression for them.
So again, putting the value of 0 from here, we will get x is equals to k dash in bracket x dash plus vt dash, and this will be our fourth equation.
So we know that x prime is equal to alpha multiplied by x minus v multiplied by t. Now let's replace x with the following equation. So x is equal to alpha multiplied by x prime plus v multiplied by t prime.
It can be a lack of argument to justify that v prime equals minus v. In this case, if you postulate that v prime equals minus v, it would be easier that you directly postulate the Lorentz transformations.
Now you can also obtain the reverse transformation. So if you imagine that the physical event happens at the origin of S frame of reference, and this person is looking at that, then that physical event is traveling in the opposite direction or in the negative x dash axis with respect to him with a velocity v, or with a velocity minus v according to this person. So using that, you can also obtain the reverse transformation equation. The reverse transformation equation is simply going to be x is equal to a x dash plus vt. So you simply replace v with...
However, since the person on the boat, as we saw before, perceives the dock to be moving in the opposite direction with velocity v, he would describe the dock's location at a position minus v t prime.
It can be opposite direction to justify that v prime equals minus v. In this case, you can justify that v is positive and v prime is negative.
Before Einstein, I would say x prime is x minus ut, and you would say x should be what you think is a coordinate plus ut.
Transformation, where we could say, all right, the Galilean transformation would be x prime is going to be equal to x minus v times t. V times t. Now we already know that if you just use the Galilean transformation, then the speed of light would not be absolute. It would not be the same in every frame of reference. And so we had to let go of the constraints that time and space are absolute. And so there's going to be some type of scaling factor involved. And so we can call that scaling factor gamma. So we could say, all right, let's just postulate that there's going to, that x prime, if we assume the speed of light is absolute, is going to be some scaling factor gamma times x minus vt. Well, you could make the same argument the other way around. If you view it from her frame of reference and you're trying to translate into my coordinates, you could say, well, x, instead of just using the Galilean transformation, that x is going to be equal to x prime, and now instead of a v we have a negative v, right? So if you subtract a negative v, in fact let me just write it that way, x minus negative v times t prime, that would be the Galilean transformation.
And according to the Galilean transformation equation, x dash is equal to x minus vt. So Lorentz consider that this relation is written as is equal to lambda into x minus vt. X is equal to lambda x dash plus vt dash.
Or it can be a fuzzy argument to justify that v prime equals minus v. We will check this third case. Criticism. There is a confusion between Galilean transformation, Galilean principle, and Lorentz transformation. In a Galilean frame, you can establish that v prime equals minus v, because x prime is the opposite of x, and it is the same time t and t prime. In a relativistic reference frame, you cannot establish it because length and time are variable. The Galilean principle is the first postulate of the theory of relativity. It says that the laws of physics in all inertial frame of reference are the same. But you have to differentiate between a law and its application. The law of the free fall is valid everywhere, on Earth and on the Moon. But by applying this same law, we are not going to find the same speed of fall on Earth and on the Moon. Likewise, it cannot be said without derivating by calculations that O and O prime move at the same speed. The Lorentz transformation makes it possible to derivate by calculation that v prime equals minus v. In this case, we derivate the Lorentz transformation by first admitting the Lorentz transformation. It's the snake that bites its own tail. It's a fuzzy argument. You did not derivate anything. Results. We did not succeed in establishing equal speeds between two different reference frames. This is due to the confusion of concepts. Confusion. And you? What do you think?